Welcome to our last video for tonight, which explains finding the parameter in compound shapes. As you can see here, we have this shape in hands, and it is composed of big semicircle and three small semicircles. So if you complete the shape here, as you can see here, the big semicircle and the three small semicircles. Of course, let me remind you, we are not calculating the area in here to think of subtracting and adding shapes together or from each other. But we are calculating the parameter if we are starting at this point and we are going all around the shape to close it. So we need to know the length of each arc in order to do so. So let's take this shape here. Let's take this shape here and let's paste it here as following. Let me enlarge it a little bit so that you can understand what we are talking about. Let's get back to the presentation. So at first, let's calculate the length of the big arc in the big semicircle. As you can see here, the 6 does not represent the radius of the big semicircle because the radius is the distance from the center of the big semicircle to the circumference. So 6 represents the diameter, which is the distance from the circumference to the circumference passing through the center of the circle. Accordingly, the big semicircle, the radius is 3 centimeters. Then write the general formula of finding the length of the arc in a big semicircle, which is half of 2 pi r. So, or we can write it 2 pi r over 2. Let's substitute the value of r, which is 3. So it's 2 times pi times 3 over 2. The 2's are going to be cancelled. So the answer in terms of pi is 3 pi centimeter. Now, the small semicircles are distributed equally along the 6 centimeter. So the diameter of each small semicircle is actually 2 centimeter. So if the 3 small semicircles are distributed equally along diameter 6, then the diameter of each small semicircle is equal to 2 centimeter. Based on this fact, we're going to calculate the length of the arc for the small semicircle, where the radius is actually equal to 1 centimeter. The 2 centimeter represent the diameter of the small semicircle. So the small semicircle, the radius is equal to 1 centimeter. Write the general formula of finding the length of an arc in a small semicircle, which is 2 pi r over 2. Substitute the value of r as 1. So it's 2 times pi times 1 all over 2. The 2's are going to be cancelled. So the length of the arc in a small semicircle is equal to pi. Let's get back to this presentation. Sorry, let's go here. So as I explained earlier, the length of this arc here is actually pi, and the length of this arc here is pi. and the length of this arc here is pi, while the length of this big arc is 3 pi. Let's imagine that this is my starting point here, and if I go around the shape to close it, so this is 3 pi, and remember the parameter is adding all sides to close the shape, adding all sides to close the shape. And if I go up all around to here, so plus pi plus, and if I carry on until here, plus pi, and back to the starting point, plus pi. So P is equal to 3 plus pi is 4 pi, 4 pi plus pi is 5 pi, and 5 pi plus 5 is 6 pi centimeter, and this is how I calculate the parameter of this shape. Back to the presentation. So we calculated at first the length of the arc in the big semicircle, and then we calculated the length of the arc in the small semicircle. Accordingly, the shaded area or the parameter of the shaded area is 3 pi plus pi plus pi plus pi. If you add them all together, it's gonna be 6 pi centimeter, and this is how we calculate the parameter of this shape. Thank you so much for your patience tonight. I hope you found the videos helpful, and I hope that you won't struggle with any problem you come across to calculate the parameter of two-dimensional objects. I'm gonna thank you once again for watching, sharing the link of this video, and subscribing to my YouTube channel. Have a good night.